Okay, we're looking at properties of matter, and let's take a look at the warm-up. It says list 4 properties of snow. So there are a number of different things you could put here. It's white, it's cold, it's crystalline, it can be slippery, it is cohesive, it's compressible, just to name a few. Name or describe 2 different types of snow. Well, you can have light snow, fluffy, heavy, wet, slushy, powdery. Suggest why there are different types of snow. Hint, think about why snow can have different properties. Well, the air could influence it, the temperature, the pressure, to name a few. And today we're going to be talking about matter and classifying matter and the different properties of matter. Let's scroll down to classifying material properties. Chemistry is the science that's concerned with the composition or what things are made of, the properties of matter, and the behavior of matter. And matter is anything that occupies space and has mass. So those two components have to be included for something to be matter. Mass is the amount of matter that's contained in something. And some common things are usually measured in grams or kilograms. And properties are the qualities of a thing. Those are things that are like qualities that are common to a group of things. And the properties can be extensive and intensive. Extensive properties are properties that depend on the amount of material that I have. These would be things like mass, volume, the electrical resistance of a copper wire because it depends upon the diameter and the length. The flexibility of a metal sheet, that depends on how thick it is. We can also have intensive properties which do not depend on the amount of material that we have. So these are things like the melting point, the density. The melting point of gold is 1064 degrees Celsius. Its density is 19.3 grams per centimeters cubed. It doesn't matter how much gold I have. Its melting point and density will always be the same. And those properties can be used to identify a substance. Other intensive properties are going to be things like temperature, concentration, tension, and every material has a unique set of intensive properties that could be used to identify it. Okay, let's go to the next page and talk about physical properties versus chemical properties. So properties of matter are also classified as being physical or chemical. Physical changes are changes of state or form, and physical changes are reversible. So this is when you're changing between a solid, a liquid, and a gas. A physical change would also be dissolving salt or sugar in water. A physical property is one that describes a physical change or physical quality of something. So this would be things like melting point, boiling point, color, hardness. Chemical changes are when we make something new. And a chemical property is something that describes the chemical change or the tendency of something to react. So chemical properties are going to be things like how stable is it? Is it flammable? Is it toxic? Does it react with other chemicals? So chemical changes are not reversible. Chemical changes are going to involve things like there's an unexpected color change that you'll notice, or we produced a gas and it's bubbling, or you produced an insoluble product, which is known as a precipitate, which we'll talk more about later. There are some properties listed down here that are also considered physical properties. Those would be things like a material's electrical properties, its magnetic properties, thermal, optical, acoustical, radiological, and mechanical. Okay, these are also classified as physical properties. If I'm talking about how a material is opaque, or it's transparent, or it's translucent, then those would also be considered physical properties. Surface tension, also considered a physical property of a substance. Okay. Let's take a look at particle relationships down here. Physical changes are when we have the same substance, we're just repositioning its particles. For instance, in the solid phase, the particles are close together, tightly packed and touching. In the liquid phase, they're a little bit further apart from each other. They can slide over each other. So that would be an example of a description of a physical change. Chemical changes are where we regroup the atoms. We actually separate them, and they recombine to form different substances. Physical changes alter intermolecular relationships, meaning those between the particles, while chemical changes are affecting the intramolecular relationships. Those are the things like the bonds. So intermolecular is between particles. Intramolecular is within particles. Okay? Physical changes generally involve less energy than chemical changes. And let's turn to the next page. Let's look at the quick check here. The first question is, what is matter? Matter occupies space and has mass, and it is the stuff that materials are made of. Okay. You may want to make a note. Every single year I have students miss this. Air is an example of matter. Even though you can't see it, it's made up of different elements in the gaseous state, and they occupy space, and they do have mass. Things that are not matter are going to be things like light, sound, and heat. Okay. Number 2, what is a property? A property is a quality of a thing. Number 3, what is an extensive property? That's a quality that depends on the amount. Number 4, what is a chemical property? That's a property that describes a chemical change. For instance, the tendency of something to react, the tendency of something to rust. Let's talk about kinetic energy. Kinetic energy is the energy of motion. It's any form of energy that cannot be stored. And the greater an object's speed and mass, the greater its kinetic energy. So the particles of matter have a type of kinetic energy known as mechanical energy because of their continuous motion. And atoms and molecules have types of motion. The first one would be called translational. That's where they're moving from place to place. The second one is rotational. That's where they move about an axis. And the third is vibrational, where they have these repetitive back and forth motions. Let's move on to thermal energy, temperature, and heat. Thermal energy is the total mechanical energy of an object's or material's particles. And this is an extensive property. Temperature is the average mechanical energy of the particles that compose a material. So particles that make up something. And an increase in something's temperature indicates the average speed of the particles has increased. So at higher temperatures, particles have a greater speed. At lower temperatures, particles have a lower speed. Okay, let's move on to the next page where they talk about heat. Heat is energy that is transferred from one substance to another because they have a difference in temperature. Heat flows from a warmer object to a cooler object. And a thermometer, if we're using a thermometer to measure the temperature of something, a thermometer is at its own temperature. So if I'm adding a thermometer into an experiment after I've set it up, then it can alter the temperature of the substances that are involved. So if I'm putting a cold thermometer into hot water, the thermometer heats up and the water cools down until they're the same temperature because the heat is going to move from the hot water to the thermometer and heat that thermometer up. So this is why when you're setting up an apparatus to do an experiment, you want to include the thermometer at the beginning of the experiment so you don't have to introduce them into a fluid later on. Let's move down here to the quick check. What is temperature? So temperature is the average mechanical energy of particles that make up a material. Number 2, what is thermal energy? This is the total mechanical energy of an object's particles. Number 3, what is heat? That is energy transferred from one substance to another due to a difference in temperature. Let's move on to the states of matter. Under normal conditions, matter exists in 3 states. It's solid, liquid, and gas. And the 3 states can be defined using an operational definition, which is going to give you observable characteristics to help us classify things, and conceptual definitions, which explain what operational definitions describe. So if you take a look at the table, you'll notice that for a solid, solids have fixed shapes and fixed volumes, and they are not compressible. The only movement that you're going to have in a solid substance is the particles will vibrate in place or oscillate in place. And the particles are going to be very compact and they are touching. And this is when you have the lowest kinetic energy. And I'm going to abbreviate kinetic energy as KE. For a liquid adopt to the shape of their container. They have a fixed volume. They are slightly compressible because there is a little bit of space in between the particles, and the particles are free to slide over one another. And here you're going to have medium kinetic energy. You have more kinetic energy here than you do in a solid. For a gas, gases have the ability to adopt to the shape of their container and to the volume of their container. They can expand and they can compress. So they're very compressible, and that's because there is a lot of space in between gas particles themselves. The particles take up very, very, very little volume. The particles are free to move and collide with each other and bounce off the walls of the container. And this is when you're going to have the highest kinetic energy. Let's go on to the next page. Let's talk about the kinetic molecular theory. The kinetic molecular theory is abbreviated KMT. You will often see that in questions and on tests and online. And this explains what happens to matter when the kinetic energy of particles changes. There are a few key points that you should know. All matter is made up of tiny particles, and there is empty space between those particles. The particles are always moving, and their freedom to move is dependent upon what state of matter are they in. Are they a solid, liquid, or gas? The particles move because of energy, and the amount of energy that the particles have is going to determine how fast they move and how far they move from each other. Now, there are some terms that we use to describe the changes from one state to another, meaning moving from a solid to a liquid or a gas. When you're freezing, you're moving from a liquid to a solid. Melting, solid to a liquid. Evaporating, which is also known as vaporization, is a liquid to a gas. Condensation, gas to a liquid. Sublimation, solid to a gas. Dry ice, for instance. Sublimes at room temperature. Deposition, a gas to a solid. Now, you'll notice over here on the right-hand side that if you're adding heat, then the phase changes that are associated with that are melting, evaporating, and subliming. So anytime you're adding heat, this is known as an endothermic process. On this left-hand side, you are removing heat. So if you're condensing, you're undergoing deposition or solidification, or you're freezing. This is an exothermic process because heat is being given off. Let's take a look at the quick check underneath. Explain the difference between the operational and conceptual definition of a liquid. So an operational definition is more descriptive. For instance, this says that if you have liquid, it is of fixed volume and it adopts to the container's shape. A conceptual definition has to do with the particle interactions. So the particles are able to slide over each other in a liquid, and there's a little bit of space in between them. Number 2, describe the differences in kinetic energy between the particles in an ice cube and a glass of water. Well, ice is going to have the lowest kinetic energy, and this is a solid, versus a glass of water. This is going to have higher kinetic energy, and this is a liquid. Okay? For number 3, how does heat contribute to a phase change? So phase changes depend on temperature. Let's move on to the next page where they talk about melting point and boiling point. So a material's melting point is the temperature of its solid as it changes to a liquid. And the particles have spread far enough so that they can slip through the gaps between the atoms surrounding them. And the melting point of a substance depends on the strength of its attractive forces between its particles. So the intermolecular forces that are between the particles are affecting it. And the freezing point and the melting point, most of the time, for most substances, are the same. Let's talk about boiling point. So boiling is a special case of evaporation. And the gas formed by a substance that boils above room temperature is called vapor. And boiling is when we have this vigorous bubbling that happens within a liquid as it internally vaporizes. And a bubble is a quantity of gas or vapor that's surrounded by liquid. And if you have a pot of water that's being heated, some molecules at the bottom of the pot are receiving so much heat and they're moving so fast that they actually bounce around and they push other water molecules away from them, and that produces a bubble. And the vapor pressure inside the bubble inflates it, while the weight of the water and air above it create an opposing pressure that makes the bubble collapse. And as the bubble rises, the water vapor molecules lose energy and the bubble shrinks and collapses before it gets to the surface. And that process just keeps continuing until you're transferring energy from the bottom of the pot to the top of the pot until all the water molecules are moving as fast as possible without entering the gas phase. And at that point, when the bubbles rise to the surface of the water without collapsing, that's when the entire pot of water is boiling. One definition of boiling point is the temperature at which the substance's vapor pressure, so that's the pressure inside the bubble, equals the surrounding air pressure. This is a very important definition that you should highlight. Now, we can lower the air pressure above a sample by putting the sample in a vacuum chamber and pulling some stuff out and drawing that pressure down to make it boil at a lower temperature. I can do that as a demonstration. We can also take it to a higher elevation. So at higher elevations, the atmospheric pressure is lower, which allows, for instance, water to boil at a lower temperature. Okay, so boiling point is also defined as a substance's highest possible temperature in the liquid state at any given atmospheric pressure. So here is a second definition for boiling. Okay, water boils at 100 degrees Celsius, and that is a definition that typically occurs at sea level. And let's move on to the next page. So, boiling point, vapor pressure, and volatility are very closely related properties that are all relevant to boiling. Volatile substances are things that readily evaporate, or they evaporate at really high rates. This would be things like rubbing alcohol or acetone, which is a nail polish remover. And these sorts of things have really high vapor pressures and low boiling points. Now, let's talk about the heat that is associated with certain phase changes. Let's talk about the heat of fusion and the heat of vaporization. The heat of fusion is the amount of heat that's required to melt a specific amount of a substance at its melting point. So this heat of fusion has to do with the solid to liquid phase change. It represents the difference of potential energy between the solid and the liquid states. Potential energy is stored energy. This can be stored in chemical bonds. And the heat of fusion is actually released when a quantity of substance freezes. And the heat of fusion is typically measured in joules per gram. They will often give you heat of fusion for various substances as constants in a table. Same for heat of vaporization. The heat of vaporization has to do with the liquid to gas phase change, and this is the amount of heat required to evaporate something at its boiling point. It represents the difference of potential energy between the liquid and the gas phases, and it is released when a specific amount of something condenses, and it indicates the strength of the force holding the liquid particles together in the liquid state. This is also measured in joules per gram. Let's take a look at the quick check. What is melting? Well, this is the process where you're changing from a solid to a liquid. What is boiling? Boiling is when you have that vigorous bubbling that happens within a body of liquid as it vaporizes internally. Number 3, what is the heat of fusion? This is the amount of heat energy required to melt a specific amount of substance at its melting point. I'm abbreviating melting point MP. Now, let's go on to reading a heating curve. When energy is added to a solid, the temperature changes. If you look at this heating curve down here, this little S is telling you that this portion of the graph is where you have a solid, and since this line is increasing, if you look at the y-axis, this is where your temperature is. So that's why you're adding heat and the energy is increasing, the temperature is changing as you follow that line along. Now, the changes in temperature that I'm going to be talking about are illustrated on this heating curve. We also can have cooling curves. And this is showing you an ideal heating curve for water. Now, this first plateau in the graph between this portion and this portion right here, or it says melting. As the solid melts slowly in its own liquid, the temperature of the liquid is not going to rise if the melting is converting kinetic energy into potential energy as fast as the heat is being added. So here you're going to have a constant temperature during that phase change. Okay? So as I go in this direction, that's when we're melting. So the moment that the first particle begins to pull away from the solid until all of it is melted, your temperature is going to remain constant. Then you have an increase in temperature, and this is the liquid here in this portion of the graph. And this is where you're increasing the temperature, and the moment that first particle begins to enter the gas phase until all of them are there, this is boiling, moving from left to right here, and this is where you also have a constant temperature. Now, over here, this is where you have your gas, and this is where the temperature is increasing as well, okay? So, if I'm talking about the heat of fusion and the heat of vaporization, you will notice down here, HF, representing the heat of fusion that is associated with this portion of the graph where you have the horizontal portion for melting. And then over here, you have HV representing the heat of vaporization over this horizontal part of the graph where it is boiling, okay? Now, if I'm talking about kinetic energy changing, kinetic energy is increasing where your temperature is increasing. So where you have your solid, liquid, and your gas, and these temperature increases are happening, this is where your kinetic energy is changing. Now, let's go on to the next page, and let's talk about reactivity. For reactivity, this refers to whether a substance reacts or to its reaction rate. And both of these properties are temperature dependent. And reaction rates depend on the path from reactants to products. And reaction rates also depend upon the concentration of reactants that are present. Chemical reactions happen because the organization and potential energy of the atoms in the products is more favored than it is for the reactants. Now there are a couple of properties, thermal properties that we need to talk about: the heat of formation and the heat of combustion. The heat that's released when a substance is formed from its elements is known as the heat of formation. What does this mean? So if I have hydrogen gas combining with chlorine gas to make hydrogen chloride, I formed a substance from its elements. Okay, that's what they're talking about for the heat of formation. This is also measured in joules per gram. The heat of combustion is released when we have a substance undergoing combustion with oxygen. Now, this is where you have some sort of a hydrocarbon, like gasoline is a hydrocarbon. It's made of hydrogen and carbon predominantly. And when you combine that with oxygen, you're going to form carbon dioxide and water. And this is a combustion reaction. And the heat of combustion is the heat that's released in that instance, which is measured in joules per gram or kilojoules per gram. And these constants are listed down here for various substances.